Hi, my name is Professor LG, and today I will talk about inductive proof. Um, Please give a thumb up and subscribe my channel. Thank you. Today the objectives are first I will talk about what is inductive proof. Then I will describe the procedure, which are three steps. Then I will give you two examples, and I also leave a homework for you. Okay, let's start. So inductive proof is a mathematical proof technique. It is essentially used to prove that an equation holds for every natural number n equal to 1, 2, 3, and so on. So if you try out all the cases by using the brute force method, usually it is impossible because the number n is infinite. So the technique of inductive proof includes three steps. First, verify the beginning number, usually the 1, and to see the equation holds. Second, assume that the equation holds when the number n equal to n. And the final step is to verify when the number n equal to n plus 1, the equation also holds. So by using these three steps, so you can verify any equation that related to a natural number. So let me explain a little bit more in detail about the three steps. So for example, you have an equation. It is S sub n equal to Fn. F here is the represent a function. And this kind of a situation you often meet when you learn mathematics, like calculus or linear algebra, or right now computer science and in machine learning. So you only got this kind of equation, but you don't know how come or why the S sub n equal to Fn. So if you understand the inductive proof, you can use this technique to prove it. It is really satisfied. So the first step is verify the first number, usually the 1 or 0, or you can verify 2. So the equation holds, which is S sub 1 equal to F1. The second step, assume when n equal m, the equation also holds, such as the S sub m equal to Fm. And the final step, very important. So verify that when n equal to m plus 1, the equation also holds, such as the S sub m plus 1 equal to F m plus 1. So here, very important, the third step usually take advantage of the second step, which means use the second step equation to complete the third step verification. Okay, let's show you first example. So this equation, the sum k from 1 to n equal to n multiply n plus 1 divided by 2. So why this equation hold? So we can use the inductive proof to prove it. Step 1, n equal 1. With the left hand, you just replace n with 1, which means the sum k from 1 to 1. only one element, which is equal to 1. The right hand, you replace n with 1. The numerator is 1 multiply 1 plus 1, 2, which is equal to 2. The denominator is 2, which is right hand equal 1, which means the left hand equal to right hand. Step 2. Assume n equal m, the equation holds, such that sum k equal to 1 to m equal to m multiply m plus 1 divided by 2. Okay, that's we assume when n equal m, the equation holds. Final step, verify when n equal m plus 1, the equation also holds. So left hand, if we replace the n with the k plus 1, sum k from 1 to m plus 1. So this summation can be separated two parts. First part, the sum k from 1 until m plus the final element m plus 1. Right? So then we can take advantage of the second step. Sum k from 1 to m is equal to m multiply m plus 1 divided by 2. Then if you simplify this formula, you will get the numerator is m power 2 plus 3 multiply m plus 2 divided by 2. So that's the left hand. Let's look at the right hand. Right hand, if we replace n with m plus 1, then we got this formula. So then we can simplify the numerator. Then the numerator will become m power 2 plus 3 multiply m plus 2. The denominator is 2. See, you can see the left hand equal to right hand, which we proved the equation, the sum k equal 1 to n equal to n multiply n plus 1 divided by 2. Let me show you the next example. Prove geometric theory formula. So what is the geometric theory? So geometric theory is the theory for which the ratio of each two consecutive terms such that a sub k plus 1 divided by a sub k is a constant. So for example, 1 plus 2 plus 4 plus 8 plus 16 plus 32, it is a geometric theory because 2 divided by 1 is 1, 4 divided by 2 is 2. So the common ratio, which is here the ratio is equal to 2. And the next one also is a geometric theory. Okay, the ratio is 0.5, right? So let's prove the summation for geometric theory, which we define the ratio is R, which is a sub k plus 1 divided by a sub k equal R. Then the term a sub k can be represented by a sub 0 r power k. A sub 0 means the first element. In this case, we start k equals 0, which is the sum a sub k, the element. K from 0 to n can be represented a sub 0, the sum r power k, k equals 0 onto n. That can be represented by this formula. Okay, so this formula is you often often see in mathematics and in computer science, like machine learning. Okay, let's prove it. Why this equation hold? First step, we prove n equal 1. Of course, you can use n equal 0, but we use n equal 1. So the left hand, if you replace n equal 1, then the left hand is a sub 0 r power k, sum r power k, k equals 0 onto 1, which is there's two elements. First element is a sub 0 r power 0 plus a sub 0 r power 1. So any number the power 0 equals 1, which means we got the left hand is a0 plus a0 r. Right hand we replace n with 1. Then the numerator will be a sub 0 multiply 1 minus r power 2. And the denominator is the same, 1 minus r. Then if you simplify this formula, you will get a sub 0 plus a sub 0 r, which means the left hand equal to right hand. Okay, we suppose that when n equal m, the equation holds such that s sub m equal to a0 sum r power k, k equals 0 onto m, equal to this equation. Okay, so the numerator is a sub 0 multiply 1 minus r power m plus 1. So the denominator is 1 minus r. Okay, so let's go to step 3. So we needed to prove that the equation also holds when n equal to m plus 1. So left hand s sub m plus 1 can be represented by s sub m plus the m plus 1 element, which is a sub 0 multiply r power m r to the power of m plus 1. So then we take advantage of the step 2, the assumption. So the s sub m can be represented by this formula, right? So then we simplify this part. We will get the numerator will be a sub 0 multiply 1 minus r to the power of m plus 2. And the denominator is the same, 1 minus r. That's the left hand. The right hand, we just replace n with m plus 1. So the numerator will be a sub 0 multiply 1 minus r to the power of m plus 1, which is identical to a sub 0 multiply 1 minus r to the power of m plus 2. So the denominator is the same, which means it's clear the left hand equal to right hand. This means that the equation holds when n equal to m plus 1. So let me do a summary. The inductive proof is an important technique in mathematics. So it includes 3 steps. The first step to verify the first number the equation holds, usually the 1. And the second step assume that when n equals m, the equation also holds. And the final step is to verify n equals m plus 1, the equation also holds. So the important thing is that whenever you prove the third step, you need to take advantage of the second step, which is to use the assumption equation to prove the third step. So I leave a homework for you to prove the arithmetic series formula by using the inductive proof technique. Okay, so and here n is the number of item, a sub 1 is the first term, a sub n is the last term. And thank you. So if you like this video, please give a thumb up and subscribe my channel. Next time I will talk about another mathematical proof. And if you have any question and or request, please leave a comment below. Thank you.